In this lesson, we want to talk about solving nonlinear systems of equations. All right, so when you get to this section, basically what you're looking at are systems where at least one equation is nonlinear. Now, solving these, it's not a hard thing to do when you get to this section, but it is tedious. And there's not one general approach. So every problem you see has a different approach or different strategy to it. So I'm going to do 5 examples that cover basically all the different types of problems that you're going to see. You might get other ones, but it's very easy to take one of these examples and apply it to yours. All right, so let's go ahead and get started. The first one's a very easy example. We have one that's not linear and one that is. So we have 2x squared plus 2y squared minus 21x minus 6y plus 44 equals 0, and x minus 2y equals negative 4. So the strategy here is going to be to solve this linear equation for one of the variables and then plug in to this kind of top equation that's not linear. Now, when you do this, you might get extraneous solutions. I'm not going to be checking things because this video is already going to be really long because this is tedious. But I advise you to check your solutions because when you solve these, you can often get extraneous solutions. So there are solutions that won't work in the original problem. All right, so let's go ahead and get started. I'm going to solve this bottom equation for x. So we'd have x is equal to, if I add 2y to both sides of the equation, I would have 2y minus 4. So once I have that, I know x is equal to this. So I can plug this in everywhere there's an x in this top equation. Okay, so I can plug it in there and also there. Okay, so that's what I'm going to do. That's going to give me an equation with just y, right? And then I can solve. So I would have 2 times, I've got to use parentheses here because this guy, I'm plugging in for that, and it's squared. So 2y minus 4, that quantity is squared. And then plus, you've got 2y squared minus 21 times, again, use parentheses when you're plugging in. So we've got 2y minus 4. And then minus 6y plus 44 equals 0. Okay, so the common thing there where you'd make a mistake is to not use parentheses. So you got to make sure you do that. All right, so once we have it set up, it's very straightforward. You just have to do a lot of simplifying, which can take some time. This guy right here, we know how to expand this. Again, this is squared. So I would square the first term. 2y squared is 4y squared. Then you have minus 2 times this guy times this guy. So 2 times 2 is 4, 4 times 4 is 16, then times y is 16y, okay? And then you'd have the last guy, the 4 squared, so plus 16. Now, this guy is being multiplied by 2. So let me just wrap this like this. We'll just move on. We'll clear that in a moment. So we have plus this 2y squared. I'm going to distribute this to each. So I'm going to distribute that to each term there. So negative 21 times 2y is going to give me negative 42y. And then negative 21 times negative 4 is going to give me positive 84. Okay. Then I have minus 6y plus 44, and this equals 0. All right, so I know I need to distribute here. So let me just kind of do that. 2 times 4y squared would be 8y squared. 2 times negative 16y would be minus 32y. And then 2 times 16 would be plus 32. So let me just erase this, and I'll just kind of drag this up. And I'll just slide this down a bit so we have more room to work. And let's think about what our like terms are going to be. So we see that we have this guy and this guy, right? Nothing else that's squared. So 8y squared and 2y squared would give me 10y squared. So 10y squared. Okay, so what else? Well, we have this guy right here, this guy right here, and this guy right here. Let me unhighlight these so we can be clear on what we're working with. So we have negative 32y, minus 42y, and negative 6y. Okay, so negative 32 minus 42 is negative 74, and then minus another 6 would be negative 80. So this would give me minus 80y. Okay, so let me unhighlight those now. And then lastly, we have the constants. So you've got 32, 84, and 44. Okay, so 32 plus 84 is 116. Then if I add 44, I get 160. So plus 160, and this equals 0. All right, let's scroll down and get some room. We'll come back up in a minute. So what I notice immediately is that this guy right here, this guy right here, and this guy right here, they all have a 0 at the end of the number. So that tells me everything's divisible by 10. So I can make this simpler by just dividing everything in that equation by 10. So this would be y squared. This would be minus 8y this would be plus 16. And of course, this would still equal 0 because 0 divided by 10 is 0. So from here, now it's very easy to solve. I can factor this. So y and y. And we know that this is going to be what? It's a perfect square trinomial, right? Because if I factor this, it becomes a binomial squared. It becomes y minus 4 quantity squared. Okay, so you can write it out the long way like this, or again, you can put y minus 4 quantity squared. So this guy only has one solution. It's y equals 4. All right, so let me erase everything. I'm just going to write y equals 4 here for your notes. And I'm going to erase everything. So now that we know that y equals 4, I can plug in a 4 for y either in the first equation or the second equation. I'm going to pick the second equation because it's simpler. So plug in there and you would say x minus 2 times, just plug in a 4 for y, equals negative 4. Of course, 2 times 4 is 8, so you can just erase that and put 8. Add 8 to both sides of the equation. You find that x is equal to 4 as well. So the ordered pair solution here would be 4, comma 4, right? An x value of 4 and a y value of 4. Now, I just want to say this one more time. When you're solving these, you have to make sure that you stop and check your answer in both equations of the system to make sure it works. I've already done that, so I'm going to be skipping that so I can make this video a little bit shorter. All right, so the next system is very easy to solve. It's when you get two parabolas, okay? So you'll notice that you have negative 2x squared plus 14x plus y minus 14 equals 0, 7x squared minus 49x plus y plus 76 equals 0. You just have y to the first power and y to the first power. No other y's, okay? But you have your x squared and your x to the first power. So if you wanted to, you could rewrite these and solve them for y. And in each case, you're going to have y equals ax squared plus bx plus c, okay? So let's go ahead and solve each one for y real quick. And I'll explain how we can quickly solve this. So what I'm going to do is just move everything to the other side since y is already over here. So I'll say this is y equals 2x squared minus 14x and then plus 14. So again, kept this on this side, moved everything to the other side. So all I'm doing is just changing the signs. Okay, that's all I did. Then for this one, I'm going to do the same thing. So y is equal to, and then I'm just going to move everything to the other side. So I'll just be changing the signs. So I'll have negative 7x squared plus 49x and then minus 76. So once you've written it in this format, remember, if I'm solving a system, I want to find the points of intersection. So where are these guys going to be equal or the same? Well, where they're going to be equal, the y values would be the same. So if this guy represents y and this guy represents y, well, I can set those two equal to each other and solve for the x value that makes that happen. Okay, so what I'm going to do is say that 2x squared minus 14x plus 14, again, this represents y here, is equal to the y from here, which would be negative 7x squared plus 49x minus 76. So when you get these, they're very, very easy to set up. Just solve each one for y and then equate the two, okay? So we'll say that we have what? If I add 7x squared to both sides, I'm going to have 9x squared right here. And let's go ahead and just cancel that out. I'm going to subtract 49x away from each side of the equation. So let's cancel that out there. And if I did negative 14x minus 49x, I would get negative 63x. So let's put minus 63x here. And then lastly, let's go ahead and add 76 to both sides of the equation. And I just want to strike that out real quick. So 14 plus 76 is going to give me 90. And of course, on this side, everything's canceled, so it's a 0. Okay, so this is equal to 0. So now we just have a quadratic equation that we've been solving forever. We know that immediately everything here is divisible by 9, right? So I can divide everything by 9 and get x squared minus 7x plus 10 equals 0. This is something I can solve with factoring again. Very, very easy. Let's go ahead and set this up. X here and x here. And to think about the factors, what adds up to negative 7 and multiplies to be 10, right? What two integers? Well, we know we could do negative 2 and negative 5, right? So negative 2 and negative 5. So if I set each one of these factors equal to 0 and solved, I would get x equals 2 and then x equals 5. So x equals 2 and then also 5. Okay, so let's erase everything. So at this point, what I want to do is plug in a 2 for x, see what y is equal to, and then plug in a 5 for x, see what y is going to be equal to, okay? So if I start out with 2, let's just use the top equation. So negative 2 times, you'd have 2 squared, so let's just go ahead and say this is 4. And then plus 14 times 2 is 28. And then plus y minus 14 equals 0. So we know negative 2 times 4 is negative 8. Okay, so negative 8. And you might as well just say negative 8 plus 28 is 20. Okay, and then 20 minus 14 is 6. So let's just say at this point we have y plus 6 equals 0. Let's subtract 6 away from each side of the equation and say y is equal to negative 6. So if x is 2, y is negative 6. And again, you can check that in each equation and make sure it is true. Okay, so I've already checked it, so I know that 2 comma negative 6 is a solution. So let's erase this and work with 5 now. So if I do negative 2 times 5 squared is 25, plus 14 times 5, which is 70, plus y minus 14 equals 0. Well, I know this is negative 50, right? Negative 2 times 25 is negative 50. Negative 50 plus 70 is 20. And then 20 minus 14 is again 6. So we know that we're going to end up with y is equal to negative 6 again. So the other solution would be 5 comma negative 6. So we have an ordered pair, 2 comma negative 6 that works. And again, it works in each. You can stop the video and check. And then 5 comma negative 6 that works as well. Again, you can pause the video and check that. All right, the next type of example is one that is best solved using elimination. So we have 3x squared plus y squared equals 3, and 4x squared plus 5y squared equals 26. All right, so what I'm going to do is eliminate the y variable. It's pretty easy to do because I can just multiply equation 1 by negative 5. So I would have what? Negative 15x squared minus 5y squared equals negative 15. Again, I just multiplied everything there by negative 5. So then this second equation stays the same. Let me just copy it real quick. And we're going to add these two together. And what will we get? Negative 15x squared plus 4x squared would be negative 11x squared. This would be gone. And negative 15 plus 26 is going to be 11. So let me erase this. And let's drag this up here. And let me divide both sides by negative 11. And we'll find that x squared is equal to negative 1. Okay. Well, if we want to get x by itself, we got to take the square root of each side. So I take the square root of this side, and I go plus or minus the square root of this side. We know the square root of negative 1, if we want to use the complex number system, is I, right, the imaginary unit. So I can just go ahead and say that x is equal to plus or minus I. Okay, so plus or minus the imaginary unit. So you can really say that you have x is equal to I, and then also negative I. Okay, so we got to plug each of these in. So if I plug in I, remember, I squared by definition is negative 1. So 3 times negative 1, because that's all I squared is, plus y squared is equal to 3. Well, this is negative 3 plus y squared equals 3. Add 3 to both sides, and we're going to get that y squared is equal to 6. Okay, so now if I want to get y by itself, I got to take the square root of each side. So square root of this side, and then plus or minus square root of this side. So y is equal to plus or minus the square root of 6. Okay, and I can't make that any simpler. So if x is I, the imaginary unit, then y is the square root of 6. And then also, if it's I, it's the negative square root of 6. So those are two different solutions. Again, if it's I, you get the square root of 6, or if it's I, you also get the negative square root of 6. All right, let's think about this other possibility here, where x is negative I. Now, we see that if we plug this into this equation here, just think about the fact that, okay, I have negative I being squared, but it's going to give me the same result. If I think about negative I as negative 1 times I, and this is squared, well, this is what? This is negative 1 squared times I squared, which is 1 times negative 1, which is negative 1. So it's still going to give me negative 3 here. So I'm going to go through and get the same result. Okay. So really, I can just say that I would have negative I comma square root of 6. And then also negative I comma negative square root of 6. So there's your 4 solutions for this guy. Again, for this one, you want to use elimination. And again, I've already checked my answers, so I know they work. All right, so the next one we're going to look at, we want to do elimination and substitution. So these generally take a little bit of time. So I have this x squared plus 8x minus y squared plus 10y minus 33 equals 0, and x squared plus 8x minus 5y squared plus 42y minus 97 equals 0. Notice how these are the same, okay? So what I can do here is start by multiplying this bottom equation by -1. So what I'd have is, let me copy the top one. So x squared plus 8x minus y squared plus 10y minus 33 equals 0. For this one, if I multiplied by -1, I'd have negative x squared. And then we'd have minus 8x plus 5y squared. And then you'd have minus 42y plus 97 equals 0. If I add the left sides together and I set this equal to the sum of the right sides, which again would just be 0 in this case, well, this is going to cancel, okay? So what I have is negative y squared plus 5y squared, which is 4y squared. 10y minus 42y would be minus 32y. And then 33 plus 97 is 64. So plus 64 here. Okay, so again, we noticed that, and let me just erase this, and let me drag this up. So again, as I was saying, we noticed that everything here is divisible by 4. So just divide through and get rid of it. So if I divided this by 4, I'd have y squared. Divide this by 4, I'd have negative 8y. And let me make that a little bit better. So minus 8y. Divide this by 4, you'd have 16. And divide 0 by 4, and you still have 0. Okay, so this is much simpler, much easier to work with. I can just, again, just factor this and say that I have y here and y here. So I'm going to say this is what? This is a perfect square trinomial. It factors into y minus 4 quantity squared. Okay, so your solution here for y is just 4. So we know y is 4. So let's figure out what x is. All right, so I'm just going to plug into the top equation. I'm going to plug in a 4 here and here. So I would have x squared plus 8x. And then I would have minus, what's y squared? Well, I'm plugging in a 4. 4 squared is 16. And then you have plus 10 times 4 would be 40. And then minus 33 equals 0. So let's go ahead and crank this out real quick. Negative 16 plus 40 is 24. And 24 minus 33 is negative 9. So I'm just going to erase this and put minus 9 there and then equals 0. Okay, let me make that a little better. Again, we have something we can solve using factoring. So pretty easy overall. If you want two integers that sum to 8 and give me a product of negative 9, well, I know I will want to use positive 9 and negative 1. So the solutions here for x would be negative 9 and positive 1. Okay, x plus 9 equals 0. The solution is x equals negative 9. X minus 1 equals 0. The solution is x equals positive 1. So I would say that you have one ordered pair that would be negative 9, again, the solution here, and then comma 4, that y value, and another that would be 1, comma 4, that y value. Okay, so two solutions. Again, I've already checked these. I know they work. Once again, you always want to check your solutions. All right, for the last problem we're going to look at, it's going to be another one that's extremely tedious, and we're going to use a combination of elimination and substitution again. So we have 3xy minus 2y squared equals negative 2. We have 9x squared plus 4y squared equals 10. So in this bottom equation, you have two variables that are squared. In the top equation, you have an x to the first power and a y to the first power and then a y squared. So the strategy here is to get rid of that y squared, and I can do that with elimination. Okay, so that's the first step. So I'm going to multiply the first equation by 2. So I'm going to have 6xy and then minus 4y squared. This equals negative 4. Okay, just multiply everything by 2. Let me just write this one again. So 9x squared plus 4y squared equals 10. If I add these two together, then I'd have 9x squared plus 6xy. And then this cancels, and it would be equal to 6. Now, before you go any further, realize that you could divide everything in this equation by 3. So 9 divided by 3 is 3. So this would be 3x squared. 6xy divided by 3 would be 2xy, so plus 2xy. And this equals 6 divided by 3 would be 2. Okay, so I always want to work with something as simple as possible. Now, I can take this guy right here and I can solve it for y. Okay, so the way I would do that is I would subtract 3x squared away from each side. And that would give me 2xy is equal to negative 3x squared. and then plus 2. Okay, so I have that, and then I could divide both sides by 2x. And let me erase this up here, and I'll say what? That y is equal to this negative 3x squared plus 2 over 2x. Okay, so we got that figured out. Now, where do we go from here? Well, what I want to do is plug into this equation here. I'm going to plug in for y. So what that's going to give me is 9x squared plus 4 times this guy. I'm going to put parentheses around it, so negative 3x squared, and then plus 2 over 2x, and this guy squared. So be very careful here. And then this is equal to 10. So this is going to require some work. So let's scroll down a bit. So let's think about this for a second. Forget about the 4. Let's just focus on this part right here. So if I had negative 3x squared plus 2 over 2x, and again, if this was squared, then it's really like I had 2 of them, right? So negative 3x squared plus 2 over 2x. Well, how do we multiply 2 fractions or 2 rational expressions? All I need to do is multiply the numerators together, put that over the product of the denominators. So this guy is just negative 3x squared plus 2 quantity squared, right? So the first one would be squared. So the negative 3 squared is 9. X squared squared is x to the 4th power. And then after I do that, it's 2 times this guy times this guy, okay? So I know it's minus 2 times 3 times 2. Well, 2 times 3 is 6. 6 times 2 is 12. And then times that x squared, okay? And then you would have plus this last guy squared, which in this case, 2 squared is 4, okay? And then over 2x times 2x is 4x squared. Okay, so we've got that worked out. Now let me drag this up here. And when you work these, you want to have a lot of scratch paper because you got a lot of stuff you got to go through. So if I have 4 times this, the 4s are going to cancel. So let me just erase this. Let me put equals 10 down here. And I'm going to get rid of this and just substitute in what I have to get rid of that. And let's just drag this up here now. And that's going to be our simplified equation. And what I want to do, if I want to solve for x, I got to get rid of this x squared in the denominator. So if I multiply through by x squared, what's going to happen is we would have 9x squared times x squared, which is 9x to the 4th power, okay? Then it would cancel down here, so I'm just left with this numerator here. So plus 9x to the 4th power minus 12x squared plus 4. This equals, I'd multiply this by x squared, so 10x squared. So again, all I did was multiply both sides of the equation by x squared to clear that denominator. All right. So at this point, we can solve this for x. I'm going to subtract 10x squared away from each side of the equation. And I'm going to say that 9x to the 4th power plus 9x to the 4th power is 18x to the 4th power. Negative 12x squared minus 10x squared would be minus 22x squared. And then we have plus 4, and of course this cancels, so it's equal to 0. You can immediately see that, again, we can divide everything by 2. And so this would be 9x to the 4th power minus 11x squared plus 2 equals 0. Now, this can be factored. You can use a lot of different techniques to factor this. You could easily use substitution, where you let u equal x squared, and then you can plug in and go through all that. Because of the length of this video already, I'm just going to give you the factored form and say this is going to be 9x squared minus 2, so that quantity, times you have x squared minus 1. And of course, this can further be broken down into x plus 1. And I forgot the 1 there. Times x minus 1. Okay? So you've got to go through and set each factor equal to 0. And so what will we have? Well, we know for these two it's really easy. The solution here would be that x is equal to 1 or negative 1. So that takes care of those two. But for this one, you need to do a little bit more work. So 9x squared minus 2 equals 0. Add 2 to both sides of the equation. Let's just go ahead and say this is 9x squared is equal to 2. Divide both sides by 9. And you would have x squared equals 2 ninths. So if I take the square root of this side and plus or minus the square root of this side, I would have what? You would have that x is equal to plus or minus the square root of 2 over the square root of 9 is 3. So that's a lot of different things to go through. So you have x equals 1, negative 1, square root of 2 over 3, and negative square root of 2 over 3. So we would say square root of 2 over 3 and negative square root of 2 over 3. All right, so we come back up here, and I'm going to use this that we found earlier, that y was equal to this guy right here. You can plug into these equations up here. This is going to be a lot quicker, a lot easier, so that's why I'm going to do it this way. All right, so if I plugged in a 1, we know that we would get what? Let me kind of do this off to the side. Y would be equal to 1 squared is 1, so negative 3 plus 2, which is going to be negative 1, over 2 times 1, which is 2, so negative 1/2. So if x is 1, y is negative 1/2. All right, what about for negative 1? Well, you would have negative 3 times negative 1 squared is 1, so you just have negative 3 plus 2, so that's negative 1. But then down here, 2 times negative 1 would be negative 2, so this is positive 1/2. So if x is negative 1, then y is positive 1/2. So let's get rid of these two, and let's work with these two now. If I had negative 3 times this guy squared, so you'd have the square root of 2 over 3, this guy squared, plus 2, and this is all over 2 times square root of 2 over 3. So if I squared the square root of 2, I would get 2. If I squared 3, I would get 9. So this would be 2/9. So this would be 2/9. If I divide 9 by 3, I get 3. So this would just be negative 1, and this would be 3. So this would turn out to be negative 2/3. So negative 2/3. Okay. So now from here we have plus 2. So let me get a common denominator going. I'm just going to multiply this by 3 over 3. So this would be 6/3. So plus 6/3. And of course this would end up being 4/3. So that's my numerator. I have 4/3. So down here, what am I going to have? Just 2 times square root of 2 over 3. Okay. So let's simplify this by just saying that we have 4 over 3 times the reciprocal of this, which would be 3 over 2 times square root of 2. Okay, so let's erase this. What do we get? Well, this would cancel with this and give me a 2. And this would cancel with this. So what I'd have is 2 over the square root of 2. And if you rationalize the denominator there, if I multiply this by square root of 2 and this by square root of 2, then what I'm going to end up with is what? This would end up being 2 down here. And of course I can cancel this. So I'd end up with just the square root of 2. So if I had the square root of 2 over 3, then I would get the square root of 2. Okay? So now we have one more to check. And I know this is tedious, but again, you're going to get problems like these, so you might as well work some. So the last one, let me just get some room going. We would have the negative square root of 2 over 3. If I squared that, again, I'd have negative 3 times, in this case, the negative would go away. Square root of 2 squared is 2. So this would just be 2/9. And we know that this would cancel and become negative 2/3. So this is negative 2/3 plus 2. And again, we wrote that as 6/3. So this became 4/3. So that's, again, the numerator. So it's 4/3. Then over 2 times this guy, which is now negative. So I would have negative 2 times square root of 2 over 3. Okay, so let's get rid of this. And of course, this turns into what? 4 over 3 times negative 2 times square root of 2 going in the denominator. Up here, you'd have your 3. Okay, so let's erase this. And let's go ahead and cancel this with this and this with this and say it's a 2 here. So what you have here, let me just kind of write this over here. We'll say this is negative 2 over square root of 2. Again, you want to rationalize. So if I multiply this by square root of 2 over square root of 2, square root of 2 times square root of 2 is 2. And this would be negative 2 times square root of 2. We can cancel this with this and just say we have the negative square root of 2. So this would be negative square root of 2 over 3. And then comma, you'd have negative square root of 2. Let me erase this, and those would be our answers. Again, I've already checked this. When you're working these, you got to make sure you check them. I know it's really, really tedious. It takes a lot of work to check them, but you could report a wrong answer if you don't. So here we get 1 comma negative 1/2, negative 1 comma 1/2, square root of 2 over 3 comma square root of 2, and then negative square root of 2 over 3 comma negative square root of 2.